Hello, this is Mr. Best. Welcome to Graphs of Functions, Part 1. We're going to be doing a couple different things in this Part 1 in terms of identifying domain and ranges, looking at increasing, decreasing, and constant functions, graphing piecewise functions, and looking at relative max and mins of functions as well. First part, example 1, given the graph, answer each question. I would pause the video right now and see if you can answer these 4 questions. Here we go. Identify the domain. The domain is your x values. So what is the smallest x to your largest x? So the smallest x is at 1, but it's not included because it's an open circle, and the graph goes all the way over to 6, and it is a closed circle, so we'll use a bracket on that side. So all values between 1 and 6, including 6. Your range is your y value. Your lowest y value on here is at -4, but once again it's an open circle, so it'll be at -4, and it goes all the way. Now you might think over here, because it stops here, it's at -2, but the range is your y values. So what is the smallest and what is the largest? Well, the largest, the highest point right there is at 4. So it goes from -4 to 4, but 4 has a bracket on it. The next question we have is find f of 6, f of 2, and f of 1. So f of 6 is equal to, when x is 6, what is the y value? 6 comma -2. So the output is -2. What about f of 2? F of 2, when x is 2, what is y? It's at 2. And then the last one, f of 1, is equal to, at 1, you go down, and there's a point, but it's an open circle. So f of 1 is actually not part of your domain, which is what we talked about in the beginning there. So f of 1 is undefined, or it does not exist. And then the last question is find x when f of x is equal to 4. So what we're saying is, what is x when y is equal to 4? When the output is 4, what is x? So you have to find 4, which is right here, and as we go over, right there, what is the x value when the output is 4? And the answer is 2. So x is equal to, actually it's 3. X is equal to 3. So once again, at x equals 3, y is 4. The next part of functions that we'll talk about is increasing, decreasing, and constant. And so you can read through these 3 different definitions, but you know what an increasing function is. If it's getting larger, as x gets larger, is y getting larger, smaller, or is it staying the same? And so from the 3 graphs, you can see the first one is increasing. As x increases, y also increases. The second one is decreasing. As x increases, the y values are going down, so they're decreasing. And then on the third one, it's constant. As x sub 1 goes to x sub 2, the y values are staying the same for that one. So you got increasing, decreasing, and constant. You're reading from left to right, and as x increases, what is happening to the y values? So in example 2, determine the intervals at which the function is increasing, decreasing, and constant. So as we read this, you got arrows on both sides, so it is going on forever. So as you read this from left to right, this graph is doing what? What's happening to those y values? They are getting larger and larger and larger. So it's increasing over the interval of x from what? From -infinity, x is increasing all the way until it gets to 2. Alright, and then what happens? Well, at 2, then, as you get larger x values, the y value is decreasing. So it's increasing from -infinity to 2. It's decreasing from 2 all the way to that point, which is at 4. So from 2 to 4, it's decreasing. And then from 4, what's happening to those y values? They're staying the same. They're all at -2. So it's constant from 4 all the way to infinity. And so that's how you identify increasing, decreasing, and constant. And so I just want to make sure we understand these are the x values, where the y values are increasing, decreasing, and constant. The next thing we're going to talk about is the relative max and mins. These are points at which the function changes its increasing, decreasing, or constant behavior. So on my graph over here, what do you notice? Where are these changes occurring? So as it increases right here, it stops and goes back down and starts to decrease. So that represents a relative max. And then at here, as you go down, at some point there, it stops decreasing and then starts to increase. So that's a relative min. And same thing, as you work your way back up, it's increasing until it hits that point, which is another relative max, and then starts decreasing again. And then one more time, it decreases until it gets to that relative min and then starts increasing again. So those are what are called your relative minimum and maximum points. Continuous is a graph that has no breaks in it, and simple definition, it can be basically traced without picking up your pencil at all. So even just a single point that's missing, that is not continuous. There are no breaks in the graph whatsoever. Discontinuous, well, if you have a break. So a graph has at least one break in the graph means it is discontinuous. I will now show you how to find a relative max or min on your graphing calculator. These values, in terms of finding them, we will find later algebraically, but for now, the only thing I'm going to expect you to be able to do is use your graphing calculator to find them. So I've kind of have your steps that you can see on your graphing calculator, and I can show you this in class as well. So we're going to approximate the relative maximum, just the maximum, for the function g that is given. So g of x equals x cubed minus 4x squared plus x minus 3. So you can see that I've taken this equation and plugged it in. And once I plugged it in, I clicked the graph button, and so you see the graph of it, and so you can kind of see where the graph, what we're going to be looking for is this point right here, that relative maximum. And from there, you go to, on your graphing calculator, calculate, which will be above the word trace. It says calc, so press second, trace, and then that first line there says value, and then the second one, 0, minimum, maximum. Well, we want the one that says the maximum. So we want the maximum. So we click on that one, and then it's going to ask you a couple questions. Right down here it says left bound. So you want to pick a point that is on the left of the maximum. So I kind of chose right there. Then it's going to say, once you click enter, it's going to ask you right bound, and so then I went and clicked on a point to the right of the relative max, and then it's going to ask you a third question, make a guess. And so your guess you want to put as close to that value as you possibly can, or at least in between the left and right bound. And then you click enter one more time, and you'll notice it'll tell you that the maximum is x equals 1.131 and so on. So it's going to give you an approximation for that value. So we will write that down. What is the approximation? We'll round to the nearest hundredth. So the relative max would be approximately 0.13. And that's for the x. And then the y would be approximately negative 2.94. We'll round the 3 to a 4 because of the 5 in the thousandth column. So that's how you identify your relative maximum, or if it's a relative minimum, you do the same thing. You just need to make sure on the calculate part that you click on minimum instead of maximum if that's what you're looking for, and yes, it does matter. The last thing that we'll be looking at is piecewise functions. This is a function that is defined by two or more equations over a specified domain. So I'm going to do one of these examples with you in the notes. Example 4, graph. So we got a function, f of x. This is two equations that we're going to be looking at. One is linear. The first one is linear, and actually the second one's linear also. But on the first one, what we want to do is we only want the values of x that are less than 0. So one of the ways we can do this is we can create a t-chart, but only graph, or only pick values that are less than 0. But we want to start at 0 because we can't pick the number directly left of 0. So we're going to pick 0, we just know it's not included, so it'll be an open circle. And then we can pick negative 2, negative 3. We also know the slope is 5, so we can graph it that way also. But if we plug in 0 and the output's 2, if you plug in negative 1, it's negative 3. If you plug in negative 2, It's -8, and then the next one's going to be off the graph, so we won't do that one. So we'll plot the point 0, 2, but at 0, 2 we're going to do an open circle because it's not included. And then we can do -1, -3, and -2, -8. And you can see that the slope is 5 on that. And then we'll graph a line through those points, and it continues to go left. On the next one, we have values that are only greater than 0. So we're going to do another T-chart. We're going to start with 0 again, but we're going to do values that are greater than 0. So once again, if we plug in 0, we get 2. If we plug in 1, I notice that we're going to get a fraction. So I'm actually going to not do 0, 1, 2, 3. I'm going to go back and say I'm going to do multiples of 3 because that'll give me nice values. So if I plug in 3, that'll give me -1 plus 2 is 1. And once again, the slope is -1/3, so I can really base it off of that as well. If I plug in 6, that's -2 plus 2, which would be 0. So at 0, 2, now I have a point at 0, 2, it's open, but this one would also be open because it's not included as well. So we'll have another open circle. If it was included, we would now fill this circle in, but it's not. So we have a point at 0, 2, open. 3, 1, so we'll go over at 3, 1, plot a point, and then 6, 0, and you can see that the slope is -1/3. And then we will graph, and you guys will use a straight edge. I don't have that on here, but then you'll graph that line as well. So what do we have? Well, this is a piecewise function. Is it continuous or discontinuous? Well, you can see that there's a break in the graph. It's an open circle, so it is discontinuous. Alright. And then name the intervals where the graph is increasing, decreasing, or constant. Well, as I read this from left to right, so we're reading it from left to right. So from left to right, the graph is going up. The y values are increasing. So it's increasing from -infinity all the way up to 0. Remember, these are your x values. So when x is 0, it stops increasing. And then it begins to go down, so it's decreasing. The y values are going down from 0 to infinity. And there are no values that are constant. And so that's what a piecewise function looks like in terms of graphing. I'll do a couple more examples on another video for you guys.